Welcome to myprojectbazaar.com. Here we are going to discuss about order implementation of a digital watermarking system for video authentication. Major problem associated with digital multimedia data transfer over internet is copyright protection. This is because digital media are easy to copy and transmit. Many researchers are also aware of the issue like copyright protection, authentication, proof of ownership, etc. related to multimedia. Many solutions have been proposed to solve those problems and are available in the literature survey. Watermarking technique is one of the popular solutions to those issues. Watermarking techniques embeds specific information called watermark into the original media so that it is not easily perceptible. That is, the viewer cannot see any information embedded in the contents. In the case of dispute over the owner of the multimedia data, embedded watermark can be extracted and it can be used to identify the owner because the watermark contains the record information. There are three important issues in the watermarking system. First, the embedded watermark should be not to degrade the quality of the image and should be perceptibility invisible to maintain its protective security. Second, the watermark must be robust enough to resist common image processing attacks and not be easily removable. Only the owner of the image ought to be able to extract the watermark. Third, the blindness is necessary if it is difficult to obtain the original image and watermark at the time of extraction. A watermark technique is referred to as blind if the original image and watermark are not needed during extraction. The process of digital watermarking involves the modifications of the original multimedia data to embed a watermark containing key information such as authentication or copyright codes. The embedding method must leave the original data perceptually unchanged, yet should impose modifications which can be detected by using an appropriate extraction algorithm. Common types of signal to watermark or images, music clips, and digital video. Application of the digital watermarking to still images is considered in this work, and these images can be captured from the video frames of the input video. If the watermark survives of many images attacks and is still extractable from the watermarked media, then the watermarking technique is called robust. In our methodology, we using discrete wavelet transformations to watermark the given message image with the given video frame. Here we use an image as a cover of message images and the video frames of each and every frames of the input video is the cover frame for the given message signal. This will embed the image into video, and finally we extract the watermarked image with a low MSC value and high PSNR value. Now I am going to explain the flow diagram of our project. In the first stage of our flow, we give the initial video file which are made to watermark the given message frame. From the each and every video frames, it will convert and apply the DWT frame to the given video. This was then checked by using motion estimations. After that, each and every frame details, it will collect the extracted DWT features from the given video frame and then give to host frame vector block. In this block, it extracts the frame as a vector file format. After that, there was an embedder. In the embedded stage, it embeds the given video frames applied with DWT features, and then the image frame which are given as a message image, which we want to watermark this with the given video. This was also made as a vector file format. The vector was arranged for each and every structures. We can combine the total limitations of the image and with the given video frames. From the extracted motion estimated values, it will check the differences between previous and present values of the frame, and then it combines the feature values which are matching to the images, and finally the embedded images was get outside of the embedded frame. After this region, we find the inverse DWT features to finalize the embedding stage. In the previous stage of the embedder result, it will collect as an image vector format. Then this was arranged it as an DWT features, and finally we get the watermarked frame. Then on the receiver side, it will be reversed process. That means the watermarked frame was first inverse proportionally to the DWT features and then given back to the vector frame arrangements, and after that finally we apply the DWT features. Then finally we get the watermarked image as a message frame from the covered frame of the given video. Thus we extract and combine the watermarked image as a message image. Now I am going to explain the running procedure of our project. In the first stage, we combine the MATLAB with Xilinx software. So here we using the MATLAB to give the input frames and the image file format as a file storage. To give the input as to Xilinx simulator, because in the Xilinx simulator the input can be given as in the text file format. So for that purpose we get the input video and image file, and then this was converted into text file format, and after that we use the Xilinx simulator and simulate the result, and finally we get the watermarked image. In the first stage we just run the main func.m file, right click it and click run file. At the initial stage it gets the input video. So here I gives original doc.avi file formats. After that the image file was read. So for that purpose I give an sample image as penguin. After getting that image and video file, Xilinx will be open. In the Xilinx tool we propose the watermarking algorithms which are embedded in the structure. The FPGA designs are fully embedded in the Xilinx simulator, and finally output will be made as a text file, and this was read by MATLAB simulator. Now we simulate the FPGA architecture designs by select simulation and select the main function and select simulate behavior model. In this, it simulates the each and every coding lines of our proposed work. Here we design the coding work in VSDL file format. And this will generate the text files as an image pixels which are watermarked result. After simulation, this will display the timing reports. The timing waveform represents the finishing stage of our watermarked representation. So for each and every file, it just reads the line, and finally it watermarks the lines, and then save the output watermarked image as a file format. After simulation result, it will display the timing diagram, and this can be closed because this representing the simulation result will be completed. After that, the MATLAB is waiting for press any key. Now just press any key to enter. After that, the frames will display the figure 3 and figure 4. It displays the watermarked image, and the final frame displays the extracted output. This is the message signal which we want to embed into the video frame. So at the final stage, the PSNR and the MSC value will be displayed. This can be compared with the existing system. Thus we watermark the input image into the video as a cover image, and then finally we extract the output result. Thank you.